Example 6, find open parentheses 1 half plus 1 half I close to the power 10. Solution, since 1 half plus 1 half I equals 1 half times open 1 plus I close, it follows from example 4a that 1 half plus 1 half I has the polar form 1 half plus 1 half I equals the square root of 2 over 2 times open cosine pi over 4 plus I sine pi over 4 close. So by De Moivre's theorem, open 1 half plus 1 half times I close to the power 10 equals open the square root of 2 over 2 close to the power 10 times open cosine times 10 pi over 4 plus I sine 10 pi over 4 close equals 2 to the power 5 over 2 to the power 10 times open cosine 5 pi over 2 plus I sine 5 pi over 2 close equals 1 over 32I. The Moivre's theorem can also be used to find the nth roots of complex numbers, as an nth root of the complex number z is a complex number w such that w to the power n equals z. Writing these two numbers in trigonometric form as w equals s times open cosine phi plus I sine phi close, and z equals r times open cosine theta plus I sine theta close, and using De Moivre's theorem, we get s to the power n times open cosine n phi plus I sine n phi close equals r times open cosine theta plus I sine theta close. The equality of these two complex numbers shows that s to the power n equals r, or s equals r to the power 1 over n, and cosine n phi plus and cosine n phi equals cosine theta, and sine n phi equals sine theta. From the fact that sine and cosine have period 2 pi, it follows that n phi equals 0 plus 2k pi, or phi equals theta plus 2k pi over n. Thus w equals r to the power 1 over n times open bracket cosine open parentheses theta plus 2k pi over n close parentheses plus I sine open theta plus 2k pi over n close bracket. Since this expression gives a different value of w for k equals 0, 1, 2, n minus 1, we have the following. Equation 3, roots of a complex number. Let z equals r times open cosine pi plus I sine. Restarting, let z equals r times open cosine theta plus I sine theta close. And let n be a positive integer, then z has the n distinct nth roots. W sub k equals r to the power 1 over n times open bracket times cosine open theta plus 2k pi over n close plus I sine open theta plus 2k pi over n close bracket, where k equals 0, 1, 2, ellipsis, n minus 1. Notice that each of the nth roots of z has modulus the absolute value of wk equals r to the power 1 over n. Thus all the nth roots of z lie on the circle of radius r to the power 1 over n in the complex plane. Also, since the argument of each successive nth root exceeds the argument of the previous root by 2 pi over n, we see that the nth roots of z are equally spaced on this circle. Example 7. Find the sixth roots of z equals -8 and graph these roots in the complex plane. Solution: in trigonometric form, z equals 8 open cosine pi plus I sine pi. Applying equation 3 with n equals 6, we get w sub k equals 8 to the power 1/6 times open cosine pi over 2k pi over 6 plus I sine pi over 2k pi over 6 closed. We get the sixth roots of -8 by taking k equals 0, 1, 2, 3, 4, 5 in this formula. W sub naught equals 8 to the power 1/6, or the sixth root of 8 times open cosine pi over 6 plus I sine pi over 6 closed equals to square root of 2 open square root of 3 over 2 plus 1/2 I closed. W sub 1 equals 8 to the 1 over to the power 1 over 6 open cosine pi over 2 plus I sine pi over 2 closed equals square root of 2 I. W sub 2 W sub 2 equals 8 to the power 1 over 6 open cosine 5 pi over 6 plus I sine 5 pi over 6 close equals square root of 2 open negative square root of 3 over 2 plus 1/2 I close. W sub 3 equals 8 to the power 1 over 6 open cosine 7 pi over 6 plus I sine 7 pi over 6 close equals square root of 2 open negative square root of 3 over 2 minus 1/2 I close. W sub 4 equals 8 to the power 1 over 6 open cosine 3 pi over 2 plus I sine pi over 2 closed equals to negative square root of 2 I. W sub 5 equals 8 to the power 1 over 6 open cosine 11 pi over 6 plus I sine 11 pi over 6 closed equals square root of 2 open square root of 3 over 2 minus 1/2 I closed. All these points lie on the circle of radius square root of 2 shown in figure 9. Sidebar, see figure 9. The sixth roots of z equals -8 have an imaginary axis as the vertical axis and real axis as the horizontal axis. Point W sub naught, W sub 1, W sub 2, W sub 3, sub 4, and W sub 5.